The reality of building AI agents. It's 95% engineering, 5% AI. Why successful AI agents are built by software engineers, not just AI researchers. There's a dangerous misconception in the AI world that building agents is primarily about prompts, models, and clever AI techniques. The reality? Building production-ready AI agents is overwhelmingly a software engineering challenge. The ratio isn't exact, but it's something like 5% AI and 95% traditional software engineering. This isn't a criticism, it's a recognition of what it actually takes to deploy AI systems that enterprises can trust, scale, and maintain. The architecture reality check. Look at the diagram showing agentic AI architecture. Notice what takes up most of the space. It's not the LLM components, it's the surrounding infrastructure, the environment, data management, the model context protocol layer, tools and integrations. The AI agent itself is just one component within a much larger system. The LLMs provide the reasoning capability, but everything else, literally everything else, is classical software engineering. This is actually liberating news for teams building AI agents. You don't need to be an AI researcher to build successful agent systems. You need to be a good software engineer who understands how to architect reliable, scalable systems. The enterprise requirements that matter most. Identity and access management. Before any agent can be useful in a real organization, it needs to understand who can access what information. This isn't an AI problem, it's a security and permissions problem that requires robust IAM integration, role-based access controls, and audit trails. Document filtering and governance. Real enterprises have complex data governance requirements, access control lists, redaction of sensitive information, PII masking, and compliance with regulations like GDPR or HIPAA. None of this is solved by better prompting. It requires sophisticated data processing pipelines. Schema mapping and data contracts. Enterprise data is messy, inconsistent, and stored across dozens of different systems. Before an agent can reason over this data, someone needs to build the infrastructure to normalize, validate, and transform it. This is classic data engineering work. Human-in-the-loop escalation. Production AI systems need graceful fallback mechanisms. When an agent encounters ambiguous situations or low-confidence scenarios, it must seamlessly escalate to human operators. This requires workflow orchestration, queue management, and notification systems. Scalable infrastructure. Agent systems need to handle both structured data, SQL databases, and unstructured data, vector stores, at enterprise scale. This means building infrastructure that can route queries appropriately, manage compute resources efficiently, and handle varying workloads. Observability and control systems. Enterprise systems require comprehensive logging, monitoring, evaluation frameworks, guardrails to prevent harmful outputs, cost controls to manage API expenses, and detailed audit logs for compliance. These are all traditional software engineering challenges. Think of agents as APIs that can reason. This mental model is crucial. AI agents are APIs that happen to have reasoning capabilities. They still need all the infrastructure that any enterprise API requires. Fine-grained access control to ensure users only access appropriate data and functionality. An agent serving the finance team shouldn't access HR records, just like any other enterprise service. Robust storage architecture that separates structured knowledge, databases and schemas, from unstructured knowledge, documents and embeddings, while maintaining relationships between them. Comprehensive tracing and lineage, so you can understand how the agent arrived at any particular answer or recommendation. This is essential for debugging and building trust. Fallback routing and error handling, because AI systems fail in unique ways that traditional software doesn't. You need graceful degradation and clear escalation paths. Integration flows that connect document processing pipelines with model orchestration through protocols like MCP, enabling seamless tool use and external integrations. The Microsoft architecture example. The detailed architecture diagram shows exactly what this looks like in practice.
Notice the complexity. Virtual networks and private endpoints for security, multiple storage systems, Azure storage, databases, container orchestration and managed identities, application gateways and load balancers, monitoring and logging infrastructure, zone-based deployment for reliability. This isn't AI complexity. This is what any enterprise-grade distributed system looks like. The AI components, the actual language models, are small parts of a much larger engineering ecosystem. Build foundations before you fine-tune. Here's the counterintuitive advice. Before you spend time optimizing prompts or fine-tuning models, build the engineering foundations. A mediocre AI model running on robust, scalable, secure infrastructure will outperform the most sophisticated model that can't handle real-world operational requirements. The companies succeeding with AI agents aren't necessarily the ones with the best AI researchers. They're the ones with the best software engineering teams who understand how to build production systems. The strategic implication. This engineering-heavy reality actually represents an opportunity. While everyone else is focused on model capabilities and prompt engineering, the real competitive advantage lies in building better software systems around AI components. The winners in the AI agent space will be the teams that treat this as a systems engineering challenge first and an AI challenge second. They'll build platforms that are secure, scalable, observable, and maintainable, with AI reasoning as one component of a much larger architecture. The future belongs to teams that can architect AI systems, not just prompt AI models, and that's fundamentally an engineering discipline, not an AI research problem.